High-pressure pumps blast air into the bulbs to form their final shape and smooth the glass out inside the mould. At this stage, the glass is still very much a liquid. But there's a delicate balancing act going on here. If the glass cools too quickly, it will shatter. So each bulb is spun out onto a long conveyor belt and taken through a series of coolers, which slowly reduce the temperature of the bulbs to 90 degrees Celsius. But this reminds us of the biggest difficulty with handling glass bulbs. They smash really easily. So why doesn't all this rough handling shatter the bulbs? Philips have devised a series of crude but effective techniques for making sure this doesn't happen. Firstly, a shaky conveyor belt. Okay, it sounds crazy, but this vibration machine singles out the bulbs and picks out the weak bulbs from the buff bulbs. If they're too weak and crack as the result of the movement, they drop down under the conveyor belt. It's like evolution. Only the strong survive. Those that don't go straight back into the furnace as cullet. It's a cycle that produces 50,000 glass bulbs an hour. That's 15 every second. As the cascades of bulbs bounce around the conveyor belt, it looks as if they shouldn't survive the journey. But every drop, twist and turn is designed to be just within the tolerance limit of the glass. But they don't just make standard light bulbs here. This factory produces 300 different kinds of bulb. The production of a fluorescent tube involves a very different procedure. Molten glass is dragged straight out of the kiln and spun into one long tube on a 50-meter conveyor belt. These are then cut down to size and heat blasted at each end. If a standard light bulb smashes, it's no big deal. But if a 50-meter stretch of glass goes, the whole production line is brought to an abrupt halt. Then, it's action stations. An alarm calls a number of men to the scene. Light bulbs may seem harmless enough, but this is in fact a dangerous job, and you've got to know what you're doing. Stanislav Pogodzinski enters the furnace. He's dangerously close to an oven burning at more than 1,000 degrees. He has only a split second to grab some molten glass and get out of there. He can't hang around or he'll be roasted. He has to do this first time. He drags the glass as it begins cooling onto the beginning of the conveyor belt and hopes it takes. At this stage, the glass is very volatile. At any moment, it could explode. These glass makers are all highly skilled, and soon they've got the production line up and running again.
For 12 years, I've been making fluorescent lights. In that time, I've made 108,000 miles of tube. That's 4 times around the Earth.
Meanwhile, back with the standard bulbs, and a conveyor belt is taking them to be transformed from glass bulbs into electric lights. A modern city at night is such an exciting, magical sight. But as we shall see, all this amazing light comes down to some glass, a little metal, a dollop of gas, and one relatively simple chemical reaction. Turning a bulb into the electric light involves a mesmerizing dance of the machines. This elegant, beautifully choreographed industrial process brings together the glass stem, the leading wires, and the holding wires. And all of these will hold the tungsten wire in place. The stem is heated to melting point. The wires are added. Then it is clamped and gradually cooled to reduce the chance of cracking. Now the stem can be married to the bulb. All that's needed is the tungsten filament itself. Tungsten is the only metal capable of producing light continuously. Any other metal withers after minutes, or at best a few hours. And astonishingly, it's not changed as the main ingredient of the light bulb since Thomas Edison perfected its potential more than 120 years ago.
The filament in the light bulb is made of wire. When stretched, it's 1 meter long. People don't realise how many machines and complex processes are needed to make it.
The problem has always been that most metals melt before they reach the high temperatures needed to produce light, or they burn out too quickly. But not tungsten. Tungsten shines white when heated at 1300 degrees Celsius. The problem with tungsten, however, is if it's anywhere near oxygen, it won't work. This is why the bulb is crucial. It keeps it in a vacuum. And just to make sure that the tungsten continues to shine brightly, it's dipped in gether, a chemical that will burn off any remaining oxygen inside the bulb at the moment it's first lit. And now for our marriage ceremony. The stem and the bulb are finally joined together. Once the bulb is sealed, a gas called argon is pumped in. This pushes out any remaining oxygen and increases the life of the tungsten. But it's not foolproof. There's still a chance the oxygen will find a creepy corner to hide in. The bulbs still have no fitting, however, so it's time to fit the metal base of the bulb, known as the cap. Just before the bulb is lit for the first time, the cap is fixed and welded to the lamp, and the contacts are soldered on. If the process has worked, there will be a puff of smoke from the gether, and the bulb will be oxygen-free. If not, the bulb will blow. Witness the birth of the bulb. Factory manager Grzegorz Lizincik prowls the plant listening to the song of all the machines at work. And there's something he finds amazing.
Every day I watch the product that has been around for 120 years, and every day I wonder why it's changed so little, whilst the production process has changed so much. So much time, so little changes.
But change is on the way. For all its brilliance, the conventional light bulb is, by today's standards, very inefficient. It's an energy-sucking device that converts just 5% of electricity into light. The remaining 95% of the energy is wasted heat and infrared light. Other kinds of bulb are being designed to be far more efficient. Fluorescent bulbs last 20 times longer and give off 75% more light. Light bulbs of the future could depend on the same chemical that keeps nappy rash at bay, zinc oxide. This could help convert electricity to light 10 times more efficiently and last 10 times longer than the conventional bulb. reducing the planet's electricity consumption by more than half. In the US alone, that's a saving of $35 billion a year. So soon, the classic, traditional light bulb could be phased out altogether. Even within their lifetime, the people who've made this deceptively simple masterpiece could be talking about the light bulb as a museum piece, an antiquated icon of the 20th century. 5 ordinary objects, 5 extraordinary stories. Coming up, another essential component of the modern world. So basic to modern daily life, it affects pretty much everything we use. The secrets behind steel. Next, on How Do They Do It? Steel, like concrete, is an absolutely essential part of our lives. Even when a product isn't made of steel, you can bet steel was involved in designing, producing, and distributing it. Just as bronze and iron defined previous ages of man, so steel defines ours. We rely on it so heavily, but few of us know what it is and how it's made. So how do you make